In this presentation, we will learn how to delete the node of a single linked list at particular positions. So let's get started. Let us suppose we already have this single linked list and head pointer is pointing to the first node of the single linked list. And here, let us suppose we want to delete the second node of this list, that is the node at position 2. I'm assuming here that this node is at position 1, this node is at position 2, and this node is at position 3. And we want to delete this particular node which is at position 2. Now let's try to understand how to delete this particular node. Here you should understand that we have to update the link part of this node first. If we want to update the link part of this node, we need to keep a pointer which will update the link part of this node to this particular address, so that this node will point to this particular node. And we will keep another pointer to delete this particular node. So in total, we will keep two pointers, and I'm naming this as previous and current. Previous pointer will point to this node and current pointer will point to this particular node. You should always remember that current pointer will point to the node which we want to delete and previous pointer will point to the node just before the node that we want to delete. So here previous pointer will point to this particular node and current pointer will point to this particular node. Let's move our current pointer towards right. And then after that, by using previous pointer and current pointer, we will update the link part of this node by using just this particular line of code, that is previous link equal to current link. We know that current link contains this address 3000 and previous link contains this address 2000. I want to replace this address by this particular address 3000. That is why I'm using this particular line of code, that is previous link equal to current link. So this address will get updated by the address 3000. This means now this pointer is pointing to this node. And then after that, by using this current pointer, we will free this node by using this free function, and then we will replace this address by null. Isn't that simple? After this, the final result so obtained looks like this. Here we have a linked list which consists of two nodes. Now here is the code which helps us in doing the same thing. First we will see our main function, and here you can see in this main function I have declared a position variable which contains value 2. And here I'm calling del post function, and I'm assuming here as well that we have a linked list already available with us where head pointer is pointing to the first node of this list. That is why I'm not writing the code for creating this list. So here this is my assumption that head pointer is pointing to this node and we already have this list. So here we will pass the address of head to this particular function del post, and here we will also pass the position variable. Instead of passing head, we will pass the address of head. As you can see, I have put ampersand in front of head, and I'm assuming here that the address of head is 600. So here I'm passing this particular address, that is 600, instead of passing this address 1000. Here you can see this is del post function where we have a double pointer head. And we have a position variable. Here this head is different from the head which we have in the main function. This is a double pointer, which means a pointer to a pointer. We know that in the main function we have passed the address of head, which is the address of the pointer. That is why we have to declare here a double pointer which will store that address, because this is the pointer which will point to that pointer. Here you can see that this is the linked list which we are available with. This is the head pointer of the main function, and this is the head pointer of this particular function, that is del post function. This pointer is pointing to this pointer. That is why it is called double pointer. Here it stores this address 600 instead of this address 1000. Apart from this, we have position variable which stores this value, that is 2. We have current pointer and previous pointer which are pointing to this particular node, that is the first node of this linked list. And here we are checking this condition, is star head equal to null? You can see over here we are checking star head equal to null and not head equal to null. We know that this head is local to this function, right? And it contains this address 600. But we need this address 1000. That is why dereferencing is required. That is, we will put star in front of head so that we can get access of this particular head. So here we will get this address 1000. Here we are checking, is head of the main function contains null? No, it is not the case. Therefore, we will not print this message, list is already empty. We know that list is not empty. It contains the address 1000. And in the next step we are checking, is position is equal to 1? We know that position is not 1. But what if position is equal to 1? This means we want to delete the first node of this list. And let me tell you, the procedure for deleting the first node of this list is different from the procedure of deleting any other node. That is why I need to write a separate code for it. Here you can see if position is equal to 1, then first we will update the head pointer of the main function and then we will free this particular node. That is the procedure we will follow. First we will update the head pointer of the main function. That is, we will make it point to the second node of this list by using this line of code. Here by using current link we will get this particular address 2000. We will store that address within this head so that it can point to this particular node. And then after that we will use current pointer to free this node by using this free function. And here after that we will update the current by null. With these steps we would be able to delete the first node of this list if position is equal to 1. Now you must understand why I am using double pointer over here. There must be some pointer in our del pos function which will point to the head pointer of the main function. This is very important because it might be possible that we are interested in deleting the first node of this list. If it is the case, then head pointer of the main function must point to the next node of this list. That means we are updating the head pointer. So there must be some pointer in the del pos function which will point to this particular head pointer so that we can update the head pointer in the main function itself. That is why double pointer is required in this case. And let me tell you, I am not interested in returning the head back to the main function. That is why I am using double pointer over here. Now what happens if position is not equal to 1? Then we will get access to this else part. Here you can see in this else part we have a while loop. And inside this while loop, we are checking this condition. Is position equal to 1? We know that position is not equal to 1, it is equal to 2. So we'll get inside this while loop. We will update the previous by current. We know that current holds 1000. So we will put 1000 address in previous. And then after that, we will update the current by current link. That is, we will replace this address by the address 2000 so that it can point to the second node of this list. We know that current pointer must point to the node that we want to delete and previous pointer must point to the node just before the node we want to delete. We can see over here that previous pointer is pointing to the first node of this list and current pointer is pointing to the second node of this list. So this code is working fine. After this, we will decrement the position by 1. That means we will decrement this value by 1 so that it becomes 1. And then after that, we'll check this condition once again. Is position equal to 1? Now you can see that position is equal to 1. So we'll get outside of this while loop. Here you should understand that we have to put this line of code first and then we will put this particular line of code. Why is that so? Because here the previous pointer must be updated first and then the current pointer. Let us suppose that position contains value 3 instead. And here after this particular step, previous will get updated by the address 2000. Isn't that so? So here we can replace this address by 2000. This means now it is pointing to this node. And then after that current will get updated by current link, which means that now it will point to this particular node. You can see that previous will always point to the node just before the node which is pointed by the current. So this will always happen. We should always update the previous first and then the current, because our previous pointer depends on the current pointer. Now as this condition is not satisfied, we will get outside of this loop and will come at this particular point. That is previous link equal to current link. We will update the link part of this node by this address 3000. That is what we are doing here. And then after that we will free the current. That means we will free this particular node. And here after this process we will put null in current. That is, we will replace this address by null. After this procedure, we'll get back to the main function and then with the help of ptr pointer, we would be able to traverse the list and we would be able to print this output on the screen, that is 45 and 3. Here you should keep in mind that I'm assuming here as well that ptr pointer is already available with us. That means struct node star ptr is somewhere in my main function. Here I'm just assigning head to ptr. That means I'm assigning 1000 to ptr. And here I'm using ptr to traverse this list and print the elements of this list. That is why I will get this output 45.3 after this while loop is evaluated successfully. Okay friends, this is it for now. Thank you for watching this presentation.